Okay, welcome to the video. This is grade 6 GLAT mathematics, and we'll be going through 5 questions from the May 2011 mathematical concepts paper. We'll actually have a discussion on the first 5 questions from that paper. So let's get started. And these questions are taken from the workbook, the GLAT workbook for grade 6. And the questions have been just very slightly modified from the original GLAT papers. So the numbers may be slightly different, but the answers that we'll be discussing today are from this workbook. So let's get right in. Question 1, and the question reads, write the number. This is 7,143,524 in expanded form. So the question is asking us to write this number in expanded form. But first of all, we need to know, well, what is expanded form? And that discussion is based on, it's from the Numbers and Number Sense, and it tells us the different forms that a number can exist in, and expanded forms is one of them. So let's see what expanded forms is here. It says, the expanded form of a number is where each numeral or each digit, according to its place in the number, is expressed as if it exists on its own. And then all of the numbers are added together. So basically what that means is we have a number like what was in the original question, and we're going to break out each individual digit in that number according to its place value. And all the other numbers around it will be replaced by the number 0. So that's what our example is showing us. In this example, this number is 2,876,254. And in expanded form, it's written with each individual digit in their correct place value, followed by all zeros. So going back to the original question, which is referring specifically to the number 7,143,524. We start with the number furthest to our left, and of course we read numbers from left to right. So we start with the number furthest to the left, which is 7. So we write down the number 7, and then everything that comes after the 7, all of the numbers following the 7, are replaced by zeros. And we see that's our first portion of the answer here, 7, and then everything else is replaced by zeros. Then we write a plus sign, and we go to the next digit, which is the 1. So we write the 1, and then everything that comes after the number 1, or the digit 1 in this number, is replaced with the 0. So this is what we have here. All of the numbers or digits following our 1 is replaced by zeros. We write our plus sign again, and then we go to the next digit, which is 4. And we see that we write our 4, all of the numbers following our 4 are replaced with zeros, and so on and so forth until we get to the very final number, which is just written by itself. It's the final number is our units value. There's no number after it, so it's just the unit value written by itself, and that's it. So here you see our number written in expanded form. We've expanded the numbers, and each digit is represented by its unique place value. Okay? On to question 2. Question 2 asks us to write the number that is needed in order to complete the sequence. So this is a number sequence. So the first thing we need to do is we need to identify what is the sequence that's happening here. We have two numbers, and then we're expected to predict the third number. So the first number we have is 59,743. The second number is 59,748. And so we ask ourselves, what change occurred from our first number to our second number? So let's look and see what rule applies here. In this instance, we have a mathematical sequence where the number is increasing by 5. Let's take a look at that. We're back at the question. We have 59743, 59748. And so we notice that the last digit, our units digit, is different. All of the other numbers remain, and the units digit has changed. And if we go according to what the note says, which the number is increasing by 5, well, certainly we can check that, can't we? Of course, we can check that. So let's go. Well, shouldn't have taken you to the answer, but anyways. So if our numbers are increasing by 5, if I add 5 to this number, I get this number. And if I add 5 to the middle number, then I get my answer, which is 59,753. So this is a mathematical sequence, and you have to kind of watch out for them. Addition sequences tend to add in certain increments or smaller numbers. Subtraction sequences decrease in smaller units. Multiplication sequences, you'll see the number expanding in larger amounts or larger units. And division sequences, you'll see a number decreasing by smaller units. So when you look at a sequence, just ask yourself, a sequence of numbers, ask yourself, number one, is it increasing? If it's increasing, then it's addition or multiplication. If it's decreasing, then it's subtraction or division. And if it's increasing by a small amount, more than likely it's addition. If it's increasing by a large amount, more than likely it's multiplication. And then the reverse, if it's decreasing by a small amount, normally it's subtraction. And if it's decreasing by a very large amount, then that signifies division. Okay? Moving on to question 3. Now this is a rounding question, and it says, name the place to which the number shown has been rounded. So we have a number, 4,293,540, and that number has been rounded to 4,300,000. So we have to identify to which place value has this number been rounded. Now, if we previously stated that we read numbers from left to right. So starting our evaluation from the left of the first number, we have the digit 4. So when we compare it to the second number, 4 is still intact. That's good. And then when we go to the next number, we have a 2. But when we compare it to the other number, the second digit in the other number, reading from left to right, that number is a 3. So the change has occurred with our second digit going from left to right. And we see that all the other numbers that follow that second digit, they've been replaced by zeros. So this is the location, the second digit in our number is the location where the change occurred or where the rounding occurred. So now we have to identify, well, what value is that? What place value is that? And so if we're looking at place value, let's see if we have a note here. Okay, so let's go back to the definition of rounding. Rounding means to replace a number with one that is, or with a number that is close to the original number. So if a number has multiple digits, then you round to the place value that's stated. And in the example shown here, we have the number 2,786, and it's rounded to the nearest hundred. How do we know that? Because our second digit, reading from left to right, our 7 changes to an 8, and everything else is followed by zeros. So then we have to figure out, well, what place value does that 7 hold in the original number? And with place values now, we are identifying place values now from right to left. We start from right to left when we're identifying the place value of a number. And so if we start from right, the first place value is our units. The 8 is in our tens position. The 7 is in our hundreds position. And remember, the change took place with the 7 from 7 to 8. So the change took place at the hundreds position. So in this example, our number is rounded to the nearest hundreds, and it goes from 2,786 to 2,800. Okay, so that's our example. Now let's apply that to our question. So we had the change that occurred with the digit 2. It became 3 instead of 2. And so now we have to figure out what's the place value. So if we are identifying our place values from right to left, this would be our ones unit, tens, hundreds, thousand, 10,000, 100,000. So the change occurred at our 100,000 position, okay? And the answer illustrates that. We went from 2 to 3, and the 2 was originally in the 100,000s place, okay? Moving on, question 4 also deals with rounding and place value. So question 4 states, from the given number, write down the following, and the number is 258,539 and 614 thousandths. Okay, so the question is asking us for two things. It's asking for the name of the digit in the thousandths place. So first we need to know where the thousandths place is. And notice that's different from thousands without a TH. The TH makes a difference. The TH tells us that the digit is to the right of the decimal place. And if it had just said thousands, THOUSANDS, that means that the value is to the left of the decimal place. So the first thing is the name of the digit in the thousandths place, and then the value of the digit 3 in the number. So we will have to find where is the digit 3 and what place value does that hold. Here's our 3. Okay, so let's look at a chart here. This is a place value chart. It tells us the position of, or the lineup of each of our place values. And to the left of the decimal point, we start off with our units, or our ones column. Then we have tens, hundreds, thousands, 10,000s, 100,000s, and millions. And we can go on to 10 millions, 100 millions, billions, so on and so forth. But this table stops at millions. And then if we look to the right of the decimal point, we have tenths with the TH, see the THS there. The TH added tells us that the number is, or the digit is to the left, sorry, to the right of the decimal point. Next, after our tenths is our hundredths and our thousandths. So what you can do is you can always draw this chart, put in your decimal place, and then you can take your number and then fill in the numbers, each digit of the number you can fill in around the decimal place. And that way you'll know exactly which position each digit in a number holds. So if we go back to our original question, where it asks us the name of the digit in the thousandths place, remember the thousandth with TH and the N is 3 places to the right of your decimal place. So in our number, the number that's 3 places to the right of our decimal is the number 4. So the 4 is in the thousandths place. And then it asks part B, the value of the digit 3 in the number. Well, let's find our 3 in the number. And it's right in front of the 9. It is to the left of the decimal place. So remember how we identify place values for whole numbers. We start at the right and we move left. So the 9 is in our units or ones place. The 3 is in the tens place. So the value of the digit 3 in the number is tens or 30. It's 3 tens or 30. Okay, got it? Good. Moving on to question 5. Question 5 is all about Roman numerals. So we're given a Roman numeral, and I'll read the question. It says, write the number that is represented by the Roman numeral MCMXCV. So we're given this Roman numeral, and we have to express it as a standard number. And it would be helpful if we knew the value of each of these Roman numerals. Each Roman numeral represents a numerical amount. So let's look at this table. Here we have a table that lists quite a number of Roman numerals. So if we go back to our question asks us for MCMXCV. Okay, MCM, that's here on our chart. It's the last item on our chart. The value of MCM is 1900. Then it asks us for XCV. So we have the first 3 Roman numerals covered. MCM, 1900. XCV. Well, this table doesn't show us XCV, but we do have XC, which is 90. And then we have V that carries a value of 5. So we have MCM, 1900. We have XC, which is 90. And we have V, which is 5. So if we put them all together, we get 1995. 1995 is the number represented by the Roman numerals. Okay, so that's our explanation of the first 5 questions, mathematical concepts questions for the May 2011 GLAT paper. And we'll continue with the next 5 questions in part 2 of this lesson, where we're going through answer keys. And I want to say that we will continue each week to go through the explanations of answers on past GLAT papers. And you can find the workbooks for these questions. They are part of a series for grades 3 and 6. It includes your language arts and your mathematics for grade 3, and then of course your language arts, your mathematics, science, and social studies for grade 6. These books are all available in a series, and we'll go through the answers for each one in no particular order. Each week, we'll work through a set of problems. If you're interested in securing a copy of these books for your child, they are available in 2 of our local bookstores. You can get them at Joseph's Bookstore, number 53 Soldier Road, and the contact information is right there, 698-3959. Or you can go to Nassau Stationers on Rosetta Street, Palmdale. Their numbers are 322-7614 or 322-7615. And of course, the major question that most people have is, well, I need the answers. Where do I find the just complete answer key? That's also available to you online. And you can go to the following site, greatminds.teachable.com/p/glat-workbook.answer-key. It's a mouthful, yes. But this is where the answer keys are located. They're online for now. They'll be available in print form maybe over summer. But for now, we have the discussion points through this webinar where we'll be discussing different questions, and then you have the online access to the answer keys. So all the best to you and your child as you prepare for GLAT, and see you next time.